Alright, so this video is going to focus on a little bit more about word problems and like applying quadratic equations, but we are also going to do quite a bit of review here. This video is polynomial equations and factoring 5b. The note should say that, the handout. So here's our goal, is to be able to do these types of things. I want you to really realize that it can be used to solve like motion problems and geometry problems. That might not happen by the end of this video, but still it's a cool thing to understand. So here's a little recap of the things that you probably do know or you should know. If you are having trouble with these things, you want to go back, it's still the polynomial equations and factoring, probably to maybe the 3s and the 4s of this, and recap those, rehash those. Oh, sorry, these problems are not all that old actually, so my mistake. This problem right here is your now you try, the number 2. I'm going to do number 1 so you can kind of see how it's done. 2 sets of parentheses, not everything divides by 3 in this case. And we are going to go over here so we have a little more space, and we're looking for 3n squared. So 3n times n will give you 3n squared. That makes sense. And now we're looking for things that multiply to negative 30. So negative 30 is, it's a lot of different options, right? It could be 30 times 1, it could be 15 times 2, it could be 10 times 3, it could be 6 times 5. So we should kind of list all the options we have for negative 30. And then start working through the list. And if we start with 10 and 3, we can do 3 and 10, or we can do 10 and 3. We're going to need our field goal posts. And we're going to need to see what we can do to get negative n, which is negative 1n. So looking at this, negative 1n, we got 10n on the inside and 9n on the outside. And this is looking pretty good actually, because if I just had a negative 10 and a positive 9n, I would get negative 1n. So the negative must be there and the positive must be there to give me those things. And at that point we're good. We're actually done it. So we lucked out. We guessed in our first try and we got it. So try 2, pause the video if needed, or circle back and do it at the end, your choice. Now we're looking at another one. As you're looking at 2, you might think about, remember it's going to be 2x times x. You're going to need multiples that numbers that multiply to 3. So 3 and 1 or 1 and 3. Make sure your outsides and insides add to negative 5x. So pay close attention to that. So just a little bit of a hint. Look at the next problem, number 3. Do all those numbers divide? Do all those numbers divide by 6? No. So we're going to have to go the two parenthesis route. Now 6n squared could either be 6n times n, or it could be 3n times 2n, right? So we don't know which it is, but we'll go with 6n times n for starters, because that'll give us 6n squared. Also 3n times 2n obviously gives us 6n squared. So we don't know what to choose, so we just choose one and we guess. Now things that multiply to positive 6 at the end there are 6 and 1, or 1 and 6. And let's see if we've got any success here. So using green for the addition, the field goals, we got 6n for the outsides, 6n to the insides if you multiply those. That adds to 12n, subtracts to 0, doesn't work, so I'm swapping my 1 with my 6. I now have on the outside 36n and on the inside 1n. 36n and 1n is 37n, so as long as they're both positive, which means these are both positive, we are good. So that's really kind of where we're at, okay? In the interest of time, it's a little bit of a longer video, so 4 you don't have to do as now you try. 2 you do. Alright, so on to the next page. We're now solving. We might not do a lot of this, but just want to give you a quick idea here. So looking for things that, let's see, we need to factor the left side. We know the whole right side is already equal to 0. So things that multiply to 7x squared, because not everything in this divides by 7. There's no GCF. So 7x times x is our only option for 7x squared. Now we're looking for things that multiply to 30, ignoring the signs. So what are our options? 30 times 1, 15 times 2, 10 times 3. There's really a lot of options here, even 6 and 5. So we try any of these, okay? So we just go ahead and try to find something that multiplies 30. So let's try 1 and 30 for now. Now if you look at this and you make the field goal post and you think about this for a second, on the outside we have 30 times 7. That is 210x. That is way too big, because now the inside's 1x. It's never going to get 37x. It's going to either get 211x or 209x. This isn't working. So 30 and 7 on the outsides wasn't a good call. We could swap them around, of course, just make the 1 here and the 30 there. And this is actually pretty good, because the outside's now 7x and the inside's 30x. Well, what's 30x and 7x? 30x and 7x, if they're both negative, will give you negative 37x. So that means if we had a negative 30 and a negative 1, we should be in good shape. But now the question becomes, can you pause the video and see what the mistake is? This is not the answer. Something's wrong. Well, the problem here is that if you take negative 30 times negative 1, the blue numbers, you're going to get positive 30, not negative 30. And so this can't work. One of those needed to be positive and one of those needed to be negative. So we're going to have to go back to the drawing board and try to figure this out. So that was a close one. It almost tricked us. 30 and 1 can go to the number graveyard. And let's see what we can do with 15 and 2. Now if I put 15 on the outside, I'm going to have a huge number, right? If I put 2 on the inside. So I'm just going to put 15 on the inside, figuring that 15 times 7 is just too big of a number and not going to help us. So now I got, let's see, 15x on the outside, 14x on the inside, adds to 29x, subtracts to 1x, not getting me 37, so I'm going to go ahead and scratch 15 and 2. Because I think if the 15's on the outside there, it's just going to be too big of a number. So I'm going to delete 15 and 2x. And I could be wrong, maybe I have to circle back, but I figure that the 15 and 2 aren't going to work, just at a glance. If I put the 10 and the 3, same thing. I'm going to put the 10 in the inside because I think it's a more realistic chance of me getting the right numbers. Because if I put the 10 on the outside, I got 70x. Here I got 10x and 21x, just 31x, or subtracts to 11x. But I need 37, so if I swap them, see the problem is now I have 70x on the outside and 3x on the inside. So quickly I can say, nah, I don't need to do that math out. 10 and 3 didn't work. So I'm down to my last set of numbers, 6 and 5, and hopefully they work, or else maybe my quick judgment wasn't right on 15 and 2 and 10 and 3. So when I put 6 and 5, I gotta put either 5 and 6 or 6 and 5. I don't know what to do, so I just have to take a stab at it. So 6 and 5. If I do the insides, I get 6x. If I do the outsides, I get 35x. I need 37x. That's not going to work. So that's going to be 41x, or subtract to 29x or something. So I'm going to change the 6 with the 5. And now I'm going to multiply the outsides. I'm going to get 42x on the outside and 5x on the inside, I believe. 5x and 42x, if I add those, it's 47x, but if I subtract them, it's 37x. And because I want negative 37x, my bigger number of those two things needs to be negative. So if my negative is on my 42, then, and that means my negative is on my 6, then I will get the right answer. I'll get negative 37. And it finally multiplies the negative 30, the negative 6, and the positive 5. So that is where we are at. So depending on who you are, I mean, if you have like an A in the course and you're feeling really confident about things, it might not be a bad idea to just go ahead and do 2 and 3. Oh, I almost forgot a step that I always complain when you guys forget. So I set the factors to 0 because this is a solving equation. And the second factor is easy. We get x equals 6 pretty quick. The first factor is different because now we have to take 7x plus 5 and subtract 5 on both sides. And we now have 7x equals negative 5, and we have to divide by 7. So this is why I've been showing you to set the factors to 0, because now we have x equals a fraction, negative 5 over 7. Believe it or not, that fraction, negative 5 over 7, if you plug it back into the purple star way up top left there, for x both times, it will equal 0. The whole thing will equal 0. Okay, so like I was saying, now we're on to these problems, and in the interest of time, I'm not sure what I'm going to go through. I would encourage you, if you have a really good grade in the class and you're feeling pretty comfortable, try number 5, okay? You don't have to try it, but I mean, I would encourage you to try it because that's where we're going. So there are a few students that are in my mind, and you know who you are. Give number 5 a try, okay? Alright, I'm going to spend one little more bit of time on a word problem here, and we got a triangle, so let me just try to organize this a little bit better. Got a triangle which is the height is 4 inches less than the length of the base. The area of the triangle is 30 inches. So let's start setting this up. Well, if the height of the triangle is 4 inches less than the base, we should use h for height and b for base. And the word is clues me in on equals. So I'm drawing my height, h for height, and the height is always perpendicular to the base, so that's why there's that box there to show it's perpendicular, 90-degree angles. So there's my base, there's my height, and the height is, so h equals is how I'm going to look at this, okay? And I'm going to say 4 inches less than the length of the base. Well, whatever the length of the base is, I've got to take 4 from that. So it's the base minus 4, right? The base, and then take 4 from that. So b minus 4. That's how you do this. H is equal to the base minus 4. If you take 4 inches from it, then you'll have the height. So h equals b minus 4, and now we need to do something with the area. We know the area of a triangle is 1/2 base times height. We can use the b and the h in that case, so we could actually just do we could just write that, and then we can just say it equals 30. So if it equals 30, we really don't need the area there. We can actually just erase it. We can say 1/2 times b times h equals 30, and that's our equation. And now if you look at the green and the purple, you start to think of this as a system of equations. That b minus 4 can be circled and replace that h. So I'm going to take my time here and show you how I'm solving this. I'm just trying to think about what I do know. I know if I have two equations with two variables, I can just substitute in. So 1/2 b times b minus 4, which we always put in parentheses. So we're going to write 1/2 times b minus 4, replacing that h. So let's erase that and put in b minus 4 instead. And then we're going to need to do anything we can do to expand this and make sure it equals 0 and try to solve it. So usually you have to expand it first. I see the 1/2 there. I'm going to get rid of the 1/2 by multiplying by 2. 1/2 times 2 goes to just 1 and cancels out. And 30 times 2, because I have to do it to both sides, gives us 60. So I got b times b minus 4 equals 60. You can't start setting factors yet to 0 because you didn't set the whole thing to 0, so you need to distribute actually. And then you're going to need to subtract that 60 after. So b squared minus 4b equals 60. And we subtract the 60, and we have b squared minus 4b minus 60 equals 0. And that red, we're just following the procedures that we know. We spent a lot of time now solving these things, so all you need to do is use what you do know to solve that red. Okay? So I guess in this sense we're going to get things that multiply to negative 60 and add to negative 4. So two sets of parentheses. 6 and 10 are probably going to be our numbers. Negative 10 and positive 6, because negative 10 plus 6 is negative 4. So it's going to be a b minus 10 and a b plus 6, and that will all equal 0. Then you need to take those factors that I'm writing out right now, and you need to set those factors equal to 0. And some of you know this in your head. You know that b is now equal to 10 and b is now equal to negative 6. But really you should write that out, okay? But if this is the case, could the base ever be negative 6? No, so I'm scratching that out, and I'm realizing that the base's length is 10. If the length of the base is 10, right, what is the height of the triangle? Well, we said the height was 4 less than the base. So if the height was 4 less than the base, we got to take the base and then take 4 from it. And that means that our height would be 6, right? Logically. And if you take area equals 1/2 base times height, you take half of the base is 5, you multiply that by 6, you get an area of 30. And you notice in purple there, the area was supposed to be 30 inches squared. So we have done a good job here. And I'm going to leave you with just one problem left. It's a rectangular garden. It's 12 feet longer than it is wide, so your variables are L and W. Use the stuff in the first sentence to make the first equation. Use the area of a rectangle, length times width, I guess, equaling 28 to make the second equation. Combine them just like we did in the previous example, and then either find the length or the width. And once you find the length or the width, you should be able to get the other one. Kind of like you're solving a system, but you're going to need to use some factoring while you're doing it. So do the best you can. I hope the video was helpful. Obviously, this one's going to take a little bit of mental effort, and we will talk tomorrow.